Oh, if only there were some way that I could replace my stomach. Okay, what we're going to talk about here are series and parallel circuits. We've already talked briefly about Ohm's law. We've already briefly talked about certain definitions and some of the symbols that we need for the circuitry stuff. So let's just talk about series and parallel circuits. So for series, a circuit is a series circuit when there's only one way to get through either that circuit or that section of a circuit. So for instance, let's here, I'll do this in purple. I'll do this in purple for series. Let's say we just take a battery source. Okay, so here's the positive, there's the negative end of my battery, and then I come out and then I put a resistor in, and then I put a second resistor in. Okay, so this is resistor 1 and this is resistor 2, and then I cycle these in. That's a circuit, and these resistors are in series. Okay, they're in series here. If we take a look at the pathing, I come out of the positive end and I go through this first resistor and I go through the second resistor, and there's not even an option for me to go anywhere. I go through both. Okay, I go through one right after the other. There's no option for me to change paths or anything. Those are clearly in series. Now let's look at a parallel. We'll do a parallel in pink. If we want to take a look at a parallel branching setup here, I'll start with a battery again. There's positive, there's negative. And for this one, let's just come out, and I like to draw them, I call them in my mind like meat sticks, but that doesn't make any sense. It's like what meat looks like in a Flintstone cartoons. Okay, I'll show you in a second. So here's one resistor, and then here is the other resistor. There's R1, there's R2, and then whoop, we come around. Like I said, I call these meat sticks in my mind because 1, I'm weird, and 2, I think of like this look right here as being like a giant, I don't know, like leg of beef that you'd see in the Flintstones where they hold it at the sides and then like eat it kind of like a corn on the cob. I don't know, but that's how I think of it. You'll have that stuck in your memories forever now because I am a weird person. But what we clearly see here is that we're coming out of the positive. We hit this junction point right here, this node, and then you've got two options to take. Do you want to go up or do you want to go down? And what's going up and down here is our current, which we use the symbol I for that, remember. We're going to have two branches of the current, I1, I2, and then they're going to whoop, come back down together. They're going to combine once again at our second junction or second node, and then they're going to come out and be the total. And as we'll continue to see, what was coming in here was actually the total current because you can't lose it. Okay, so that's a parallel branch right there. You can do two things. Now it is possible for us to have a parallel branch that has series in it. You could do that just by saying, look, here's a battery plus minus, and here is a resistor up here, and then down here there's a resistor and there's a resistor. Whoop. Now we see that these two bottom resistors, these are technically in series. They're one after each other. You cannot make a change in path to go through them or around them. And then we see that the one up top, well, let's do this in blue. This one up top is actually in parallel with both of these in the bottom because we were able to make a decision back here. Do we want to go up or do we want to go down? Okay, so we can like have a combination of series and parallels things in circuits. We'll get more used to looking at them as we go along. What we're going to do in our next video is we're going to take a look at how to add up resistors if they are in series and if they are in parallel. And then later on we'll do some more complicated examples of what do you do whenever you've got, you know, this both thing going on. Okay, so until next time, you take it easy out there. Have a good one, and adios. This is finished.